Hello everyone and welcome back. My name is Mr. Covalt, and in this video I'm going to show you how to write the molecular, complete, and net ionic equations for the reaction of strontium nitrate with potassium sulfate. So let's get into this. Okay, so here we have strontium nitrate with potassium sulfate. Those are our two reactants. As you can see, we're given the names of these compounds, and so we need to convert that and translate that into formulas. So if you don't know how to do that, or if you're a little rusty, see my video on how to name ionic compounds and how to go back and forth between the name and the formula when you're doing that. So I'm going to go over that fairly quickly in this video. So the first thing is you got to recognize that the name of the compound is just the name of the ions put together. So the first part is your positive ion, so strontium. So strontium is Sr, and that's in group 2. So we know that that has a 2 plus charge. And the reason we know it's a 2 plus charge is a couple of reasons. One, we know that the rule is if you're in groups 1, 2, or 3A of the main group elements, then your positive charge is equal to the group number. So since strontium is in group 2, that's going to be a positive 2 charge. The other way we know that is by keeping in mind the number of valence electrons that your elements have. And so we know that the number of valence electrons of your main group elements is based on the group number. So the group number is the same as the valence number of valence electrons. So again, since strontium is in group 2, it has 2 valence electrons. And so that means that because we know that all atoms want to be like the noble gases in their configuration, so they want to have a full outer shell, and they're going to lose or gain electrons to get that full outer shell, which is about 8. So strontium has 2 valence electrons. All it has to do is just get rid of those 2 negative electrons, and it'll be happy. So when it loses those 2 electrons, then there will be 2 protons that have a positive charge that will no longer have electrons to balance out the charge. So that's where the 2 plus charge comes in. So that's going to be a 2 plus charge. And nitrate is a polyatomic ion. So you just need to know what the formula is for the polyatomic ion as well as the charge. And so I'm sure your teacher gave you some sort of handout with commonly memorized polyatomic ions and wants you to memorize those. So make sure you know that. I have a video on naming polyatomic ions and noticing the patterns that will help you remember what the charges and the formulas are. So if you need help with that, please see my video on polyatomic ions. So nitrate is NO3, and it has a -1 charge. So now that we have the 2 ions, we can see that the -1 charge and we have a 2 plus charge. And when you're writing the formula, the idea is that you have to balance 2 charges. The plus charge and the minus charge have to cancel each other out. So I need 2 nitrate ions to balance out the charge of strontium. And so it'll be 2 for this and 1 for that. Another way is to use the crisscross method. So the crisscross method is where I take the numbers of the charges and I crisscross. So there's a 1 there, and I put them as subscripts. We don't write 1s as subscripts, so that way we just write the strontium. So I'm going to have Sr, and then I have 2 nitrates. So I'm going to have parentheses. So NO3 parentheses and 2 on the outside. So notice that I'm using parentheses for my polyatomic ions. So make sure that if you have more than 1 polyatomic ion, you put it in parentheses and you have the number on the outside of the parentheses. If you only have 1 polyatomic ion in your formula, don't use parentheses. Okay, so now we have our first reactant. We'll do the same thing for our second reactant. So here we have potassium. That's K. It's in group 1A, so that means it's going to have a +1 charge. And sulfate is another polyatomic ion. We just have to know that that is SO4. and there's a 2 minus charge. Once again, I have a 2 minus, I have a plus 1, so I need 2 pluses to balance out the negative 2. So that means I need 2 potassiums, or again, I could do the crisscross method, right? So 2 down here, 1 goes down there. We don't write the ones, so this is going to be K2 and then SO4. So that's my other reactant. So K2 SO4 goes here. And now I'm ready to do my products. So to write the products, first I have to recognize that this is a double displacement reaction. And it's really easy to know that this is the double displacement reaction because I have 2 ionic substances. So the ions can switch partners. So how do I do that? So the inner ions come together and the outer ions come together. So when you put the ions together, you need to balance the charge. So strontium, I know, has a 2 plus charge. Sulfate has a negative 2 charge. They're equal in charge, so that means I only need 1 each. So that's going to be SR SO4. So that's one possible product. And now I can take the inner ions. I have potassium, which is a +1, and I have nitrate, which is a -1. Again, the charges are equal, so I only need 1 each to balance the charge. So that's going to be KNO3. So now that I have my products and I've got the balanced charge, I got the correct formulas for my products and my reactants. Now I just need to balance the equation and then make sure I write down the states of matter. So let's go ahead and balance this. So I have 1 strontium here. I have 1 strontium here. That's balanced. I have 2 potassium here, but I only have 1 here. So I'm going to need to put a 2 coefficient. I don't change subscripts. I'm only writing coefficients. Don't change the formulas, okay? So now I have 2 potassium, 2 potassium. I have 2 nitrates here because I have the subscript 2. And I have 2 nitrates here. So that is balanced. And I have 1 sulfate here, 1 sulfate there. So that's balanced too. So here I have my balanced molecular equation. So my BME balanced molecular equation. Now the last thing I need to do is figure out the figure out the states of matter. And that's what you're going to need here is some sort of solubility rules or a solubility chart. Your teacher probably gave you one, or you can get one easily on the internet. But you're going to need to know the solubility rules or a solubility chart to do that. So if we look at nitrates, if the solubility rule for nitrate is that all nitrates are soluble, there's really no exceptions to that. So if you've got nitrate, it's a soluble, it's going to be dissolved in water, it's aqueous. So this is aqueous. Sulfates are soluble as well. There are some exceptions to that. So it says here on my chart that some exceptions are silver, lead 2 ion, mercury 1 ion, barium, strontium, and calcium. We don't have that. So this is soluble. So this is aqueous. Okay. Now, what about our products? So did we form a precipitate? That's the question. So here again, we have sulfate. Again, we said sulfate is soluble unless it's got an exception. So is strontium one of the exceptions? Yes. Strontium is the exception or one of the exceptions. So in this case, this is not soluble. So it is a solid. So that is a solid. And again, what I said before about nitrates are soluble. There are really no exceptions. So that is aqueous. So here we go. So this is our balanced equation. We have a precipitate, strontium sulfate. So now we can go ahead and do our complete ionic equation. So for the complete ionic equation, all we do is we take the aqueous substances and we split them into their ions, because in reality, those ions are not together. So anytime you have something that's aqueous, especially if it's an ionic substance, the ions are separated, floating around in solution. So they're not together. So the complete ionic equation represents that more easily. So we're going to separate our ions. So I have one strontium. So I'm going to put strontium 2 plus aqueous. And you'll notice that when we separate the ions have their charges. We don't write the charges when they're in their compound form, in their molecular form, but in their separate ions. And again, these are not molecules, but we're writing them as if they are molecules. That's why we call it the balanced molecular equation. Here, the complete ionic equation is we're completely separating everything into their ions. So we have strontium plus, now notice we have two nitrate ions. These two nitrate ions are not together. So when we have a subscript, we're going to rewrite that as a coefficient. So here we're going to write that as a 2, and we're going to have NO3 minus aqueous. So if we kept the 2 there as a subscript, that would be like saying that we have these two nitrate ions that are bonded together, and that's not what we're saying. So we don't want that subscript. So you got to write it as a coefficient. So now we're done with that first reactant. Now we can do the second reactant. We have 2 potassium, so we're going to write the subscript as a coefficient, and it's going to be K plus aqueous plus the 1 sulfate, so SO4 2 minus aqueous. And now we can do the same thing with our products. Now, the only thing we're not going to separate are solids, liquids, and gases. So if you have a solid, liquid, or gas as a product, you're not going to separate those. Okay, so here we have a solid, so we're going to keep that the same. So that's going to be SrSO4 solid. And then here we have aqueous. We're going to separate that. So we have 2 potassium nitrates. So that means we have 2 potassium 2 plus aqueous plus, and we have 2 NO3 minuses aqueous. And here is our complete ionic equation, CIE. And so here you can see everything is the way it is normally. So this would be like if these two were separated in their beaker. So this is in a separate beaker, and this is in another beaker. So before we mix these together, they're in their own beaker. So we have a beaker with strontium and nitrate ions, and we have another beaker with potassium and sulfate ions, and they're floating around in their respective beakers, not doing anything. And then on the product side, we're going to be mixing. We mix them together in one beaker, and what happens? A solid forms, and you get these ions left in solution. So when we write our net ionic equation, what we're looking for are the spectator ions. We're going to eliminate the spectator ions from our complete ionic equation, and we're going to be left with whatever is part of the reaction. And that's why we call it a net ionic equation, because the spectator ions have been removed. So think of it like your paycheck. Your net pay is where after taxes are taken out. So we call this a net ionic equation after the spectator ions are taken out. So what are the spectator ions? There's a couple of ways you can identify the spectator ions. First of all, the obvious way is whatever ions are making the product that is forming, like a precipitate, those are obviously not spectators. They are involved in the reaction. So these two ions, strontium and sulfate, are not spectators. So anything else would be a spectator ion. Another way is to notice what ions stay the same on both sides. If you have ions here that are aqueous and they're still aqueous over here, those are spectator ions, right? So notice I have strontium here as an aqueous, but strontium here is part of the solid, so that is not a spectator. But nitrate, I have two nitrates in the aqueous phase, and here I have two nitrates still in the aqueous phase, so that is a spectator. So we can get rid of our spectator ions. And the same thing with potassium. I have two potassium aqueous here, and I have two potassium aqueous here, so we can get rid of that. And then what's left over is the net ionic equation. So we just write what's left over. So I have my Sr2 plus aqueous plus, and then I have my sulfate SO4 minus aqueous, and that gives me my solid SrSO4 solid. And so this is my net ionic equation. And so there you have it. I hope this video was helpful. If you like this video, if this helped you learn, please make sure you hit the like button and put a comment in the comment section. Let me know what you think. Let me know if you have any other questions you want me to go over. Please subscribe to my channel and hit the notification bell so that you can be notified by my other videos that I will put out. Thanks for joining me. Have a great day.